Hi, this is Jeremy Johnson. I'm the Director of Product Management at Silver Spring Networks. I'm going to talk to you a little bit today about how we use batch processing and stream processing and have married the two at Silver Spring, specifically for critical infrastructure and critical infrastructure IoT applications. So first, a little bit about Silver Spring. Silver Spring Networks is a leading critical network infrastructure provider. Basically, what we do is we started off in the smart grid space, deploying smart grids throughout North America, Australia, and then the rest of the globe. We have gone from smart grids, which are typically meters and other devices on the distribution topology, into also gas and water metering, as well as street lights. And one distinction I would make about our company is that we create the technology. One distinction I would make about Silver Spring is that we make the technology that connects devices. We don't make the devices themselves. So we don't actually make meters. We don't actually make street lights, but we make the communications technologies that go inside those. We also make the software that connects them. Specifically, the software that I run at the company is called the Silverlink Data Platform. The Silverlink Data Platform is a hybrid analytics and application enablement platform. The reason that it's a hybrid is that, number one, we don't feel like there's any one company that can satisfy all the application needs for critical infrastructure IoT, and therefore it would be best for us to figure out a way to get data in, get it organized in suitable formats for various workloads, and then make that data available to other application developers. We typically think of applications in terms of three areas. There are direct-to-consumer applications, there are IT applications, so this is about the actual operation of the networks and operation of software, as well as OT applications, and this is, basically the operation of the infrastructure itself. One of the big problems that we found when we started this journey was that typical architectures at a utility include a number of legacy systems organized generally around an enterprise service bus. And what this causes is it causes the prime problem in this space is actually getting data from those systems and from new devices that are being attached to those systems into a place where it can be organized and combined and analyzed. So our first step was sort of look at data ingestion and then start dealing with it in terms of real time and batch, so that we could then make it available. And what we realized is that very quickly we learned that data ingestion and real time analytics basically became the same thing, because as we're organizing data, we have to contextualize it. So for example, there are a number of alerts and events coming in from the network constantly, and there are also scheduled read events that happen throughout the day. And as that data comes in, it needs to be contextualized. It needs to be added. The data itself needs to be enriched with location information, with device information, etc. And simply storing the values isn't good enough. And so that's where we turned to DataTorrent, and actually started the project with them on an enrichment process during data ingestion. And as Mike said, it also handles some of the ETL functions. So as we're enriching data, we're also transforming it and loading it into our batch layer so that we can handle a number of different workloads downstream. Those include things like long-term analysis and forecasting, real-time and historic time series data, and also relational data that can be attached to BI tools so that operators can explore their data and discover new insights that maybe they weren't aware of before. Once we do all that stuff, we make the data available via via a secure API layer, and offer each of the operators the ability to self-service manage their data and authorize different applications to attach to that data. Thus far, we have a number of very interesting applications that range from consumer engagement, where we can do load disaggregation on energy usage. This is an interesting one where we can take a look at where we can do analysis against high-frequency meter read data and distinguish the different loads on a network so that we can provide consumers with better information about what in their home or their business is actually using the majority of energy. We also do things around network management and security for network operators to maintain a high level of availability and optimal network structures. We also do something that we call demand-side management. And this is the one that I'd like to highlight today. Demand-side management is basically the principle is that throughout the day, the energy consumption curve increases as people go to work and start using energy in business, and then it shifts, load shifts as the workday ends and people go home. Most of the time during the summer, especially in hot places like California, the demand curve increases rapidly during the day as air conditioners come on, and in some cases that can cause too much strain on the network, on the distribution network, which requires utilities to either buy energy on the open market and pull more energy into their system, or to turn on what they call peaker plants. Both options are very expensive, but they're both necessary to avoid those rolling blackouts that sometimes happen when load isn't managed appropriately. So what we try to do with demand-side management is we say, let's try and shed some load from the grid during high demand. So first of all, we have to predict, and this goes back to the model that Mike is talking about earlier. First, you have to predict, and then when you detect that there's a situation that requires a load shed event, we leverage the Silver Spring network technology to go ahead and send a signal out to participating consumers who've opted into a plan that allows us or allows the utility to take some control over the thermostat or pool pumps, other high energy draw appliances, and then in order to shed some load. Now, this is obviously not something that the utility wants to do too frequently because it can be disruptive, and these programs are best suited when they're when they're the least invasive. So you don't want to be sending these signals too frequently, and when you do send them, you want to make sure that you're sending them to enough consumers that actually it's taken effect. And this is where the streaming analytics comes in. So now we've set a signal, we've tried to curtail some load. Now we want to actually measure in real time to figure out how much load we've actually shed, and if we need to go ahead and shed more, or if we can back off on the program a little bit, just so that we can impact the fewest number of folks as possible. So I pretty much talked through this slide already, but the way that this happens is immediately after sending a load shed event to the meters, this triggers the meters to start streaming data in real time back to our real-time stream processing, and the DataTorrent process actually enriches those streams with metadata so that it's contextualized. We know where the event is having the most effect. We know where the event is not having the most effect. We can also have a rolling summation across different areas, across the total service territory, and we can also look at the variance in real time so that we can see really what the effect is of the load shed event. And then we make those results available to the utility via an OpenADR API, where they can do a comparison about what the effect of the event was versus what they expected it to be. And they can also apply some machine learning capabilities to it, so that the next time they can make more accurate predictions and also make more accurate load shed signals to the net.